which came up in 1940s, combined the ideas of Darwinism and mutation theory in the light of the available knowledge on Mendelian inheritance, variations and all that. So according to Neo-Darwinism, evolution is the result of several mechanisms that lead to variations. Several mechanisms responsible for variations cause evolution. It may be mutation, it may be genetic recombination, it may be genetic recombination, it may be isolation, individuals in a population getting isolated by barriers, isolation and natural selection. Populations of individuals form small pockets of distribution, and these small pockets of distribution are called demes. The sum total of all the genes in a population or in a deme, sum total of all the genes in a population or in a deme is what is called as gene pool. Suppose this is a deme. In this deme, let me call it as deme A. There is a collection of different genes. So this is the gene pool of deme A. There is another deme, deme B. It has its own gene pool. It has its own gene pool. As long as deme A continues inbreeding, members breeding among themselves, the gene pool remains the same. Similarly, for deme B, the gene pool remains the same. Suppose suppose there is interbreeding between members of Team A and Team B. This interbreeding will result in the appearance of a new gene pool. A new gene pool. So according to Neo-Darwinism, any population tries to maintain a genetic equilibrium. Every population tries to maintain a genetic equilibrium wherein there is no change in the gene frequency, the frequency of individual genes to its alleles, that is called gene frequency. So as long as gene frequency is not altered, genetic equilibrium remains the same. Suppose there is a change in the gene frequency. A change in the gene frequency. Such a change in the gene frequency causes variations, therefore it leads to evolution. So this change in the gene frequency is what is described as genetic drift. So mutation, genetic recombinations that occur during sexual reproduction, change in the gene frequency, isolation and natural selection. These are the factors that are ultimately responsible for evolution. Let us now examine the example of evolution of long necks in giraffe. According to Lamarck, stretching of the neck continuously generation after generation resulted in the neck becoming longer. Ultimately, only long-necked giraffes survived. That is what Lamarckism says about giraffes. Suppose we examine this example in the light of Darwinism. According to Darwinism, in the population of giraffes, there were a few individuals with long necks. This was a variation. This variation, however, was found to be useful. When there was a scarcity of food, these individuals could reach the leaves of taller plants. Therefore, nature selected these individuals with long necks to survive and eliminated the others. But Darwinism fails to explain how some individuals developed long necks. The same idea is explained by mutation theory as a sudden mutation was the cause of increase in the length of the neck. So how did a few giraffes had long necks in a population? According to mutation theory, it was the result of mutation. Therefore, natural selection operated and these individuals survived. Neo-Darwinism interprets this same example in the light of gene pool, that is, there were teams of giraffes. In some teams there were giraffes with long necks. They started inbreeding with giraffes of short necks. So gradually the number of giraffes with longer necks increased. That was an advantage for the purpose of feeding on the leaves from taller plants. So in the course of time, the long-necked giraffes survived because of natural selection, and short-necked giraffes got eliminated. So that is how evolution of long neck in giraffes can be explained, particularly in the light of the modern theory on evolution.